Chapter 7, Part 2, Power. Now, power is a measure of how fast work is done. In mathematics, we write power is equal work done divided by the time needed to finish this work. And that's why we say that power, it measures how fast work is done. It is the rate at which work is done with time. For example, you could have more power running up the stairs than climbing the same stairs slowly. Because as you run, you are moving your body fast in shorter time. Because the time is short, so you are having more power than climbing. Twice the power of an engine can do twice the work of one engine in the same amount of time. Or you can say twice the power of an engine can do the same work of one engine in half the time. So a high power engine does work fast. Of course, an engine that delivers twice the power of another engine doesn't necessarily mean it will produce twice as much work. It means that twice the power means the engine can do twice the work in the same amount of time, or you could say it can do the same amount of work in half the time. For example, a powerful engine car can get an automobile up to a given speed in less time than a less powerful engine can. Unit of power. From the equation, we find that the unit of power is joule over second, and that's what we call the watt, after James Watt, the developer of the steam engine. So 1 joule per second is called 1 watt. Kilowatt means 1,000 watt. As a general information, in the United States, usually engines are rated in units of horsepower, while in electricity, they are rated in kilowatts. However, in the metric system used in many countries around the world, engines are rated in kilowatts. 1 horsepower is the same as 0.75 kilowatt, so an engine rated at 134 horsepower is about 100 kilowatt engine. Question here. A job can be done slowly or quickly. Now both may require the same amount of work, but different amounts of course, the answer is power. Power is the rate at which work is done.